Can you see my screen?
Yep.
Hi everyone. Good evening. Welcome to 17th Toronto MuleSoft Meetup. So today's topic would be anytime runtime fabric on self-managed Kubernetes. So Mani would be walking us through the Anypoint Runtime fabric on self-managed Kubernetes. So that will be a topic for today evening. And a quick intro about the MuleSoft organizers, Meetup organizers. So we don't have Mahesh and Anurag today. So I'll just introduce myself. So my name is Kishore. I'm working as a senior manager at BMO Financial Group. I have 16 years of experience in integration and API development. So previously I was working at MuleSoft as a solutions architect. So that's pretty much about me. And next we can Money, you can go next.
Hi everyone. My name is Mani Rautrai. I'm doing integration for almost 21 plus years, I think. And for the last 8 years, I'm doing MuleSoft. I'm a certified integration architect in MuleSoft in the cloud platform. So that's pretty much what I do. A lot of speaking engagement. I work with Extevia. We are a premier partner to MuleSoft, and we have done large implementations in MuleSoft, and we are kind of a solution-driven company when it comes to MuleSoft. And so that's about me.
Sure. So the typical safe harbor statement, both speaker and the organizer, both of them are like participating in this event in the capacity, individual capacity. So before like purchasing or like doing anything with the product, so we recommend just going and looking at the MuleSoft documentation. So this presentation, whatever money would be giving is strictly for the learning purposes, and organizer or presenter do not hold any responsibility for the solution that we are presenting as part of this meetup. And this presentation is not for any promotional activities. So coming to the question and answers, right? Typically, when you go post your question and answers in the general chat tab, your question and answers might be lost. So, like, please post any of your questions in the Q&A tab so that it will be easy for us to sort out. And then at the end, maybe we can go over your questions. So how does the quiz work? So as part of the event, you will be like we will be posting questions, and then like whoever would be answering these questions, they may be able to win vouchers. And so there are some limitations on the number of vouchers that you could get. Only like you can get one voucher per month. It doesn't matter whether it's this event or a different event. If you have already like won a voucher, then you'll not be eligible for any other vouchers in this month. And also if you're already a meetup leader then or meetup ambassador, then even in those scenarios you're not eligible for the vouchers. So that's pretty much about the vouchers. And so if you are one of the quiz winners, right, typically as part of the event, if you are picked as one of the quiz winners, then we would be requesting you to provide your email address, and then maybe we will be sending you the instructions to get the voucher after the event. So we would be sending an email, and you might be filling a Google form to request for a voucher, and it would take 10 business days for you to get a voucher. And in case of any queries or questions, right, you may be able to post your queries and questions at the URL that you're seeing on the screen. And then, like, yeah, in case if you are taking any pictures as part of this event, you could go like put them in the LinkedIn or any Twitter. You can use the hashtag that you're seeing on the screen. And also, please fill out your feedback and survey, or you can send an email to meetups@mulesoft.com for any of your feedback, or any if you have any suggestions, or in case if you're looking at any like organizing any events with any of the topics, then please feel free to send an email to meetups@mulesoft.com. So that's pretty much from me, and Mani, over.
Okay,
I'll be stopping my screen share now. You can take over and you can start presenting your screen.
sure. see an infinite loop, right? Okay. So let me get started. So you guys can see my screen, right? Kishore, good.
Yeah, I can see your screen.
Okay, is audio good, right?
Yeah. So yeah,
Okay.
we yeah. So
Okay. So this is how we're going to spend our next 1 hour or so. Um, so we will deep dive into Anypoint Runtime Fabric on self-managed Kubernetes, and then we'll do a demo. And that's just in a um, broad way we'll be spending time. And the demo is our focus today. I won't be talking too much initially because as and when we do the demo, you'll learn what other features we are kind of discussing today. So mostly demo driven in nutshell. But I'll do. I mean, I will speak a little bit about ingress controllers and all that. So we'll learn that soon. So Anypoint Runtime Fabric, right? This one is a container service. I mean, so think of this way, like you guys are already exposed to on using Cloud Hub for a long time, right? And you have also used Anypoint platform on-prem, the runtime on-prem. At least you know the difference between them. One, Cloud Hub is a container offering, which is completely managed by MuleSoft, and then what you manage on-prem was your traditional, the Mule runtime versions, right, on a virtual machines. Then there was a gap needed, like it cannot be either this or that, right? I'm with the cloud migration already happening in most of the organization. There was a need that we would like to do cloud or cloud-like quote unquote solutions in a very containerized manner, but we would like to have more control over the things. When I say more control over the containerization of the things, more control over the clusters of the Kubernetes, all that. Because in Cloud Hub, it's all done by MuleSoft, right? And so there was a need, there was a void which MuleSoft filled, kind of offering the customers, okay, you can do your cloud-like solutions on-prem with the MuleSoft, and which will be compatible or in harmony with your existing cloud investment. Like many of the customers, they're already either powered by Azure or powered by AWS or powered by Google Cloud, right? That's what most of the shift is happening. And I would say, and you don't want to have your integration layer which is just sitting completely outside of your cloud platform and sitting on an Amazon cloud which is out the Cloud Hub, right? I mean, many organizations didn't prefer that way. They want to have a complete one-stop solution for their overall cloud platform. Let's say if they are running on Azure, they want Mule to be on Azure too, and with all the things cloud, right? They want that kind of a unified look and feel of their clusters or Kubernetes cluster and all that. So this is where MuleSoft's offering for a self-managed Kubernetes. Basically, what Mule is doing here, it's giving all the things like you do get your isolation between applications, right? That's the whole point about Cloud Hub or a cloud-like solutions. You can do multiple versions of Mule runtime. You can do rolling updates. You can scale up, scale down with replicas, right? All the good things about Cloud Hub, what you have been using it. Now you just do that on a typical public cloud platforms. And so it's kind of think of this way, it's like a bring your own public cloud Kubernetes, I would say, right? I mean, the typical public clouds. And even though a lot of things reside inside of like I'll take you to, well, I'll go back to that later. So I mean, so far we know runtime the overall runtime fabric has two flavors, right? One, you what I just explained now, like you do that a flavor which comes with your own Kubernetes offering, or bring your own Kubernetes offering, be it AWS GKE or EKS, Amazon's Kubernetes service, Elastic Kubernetes service. So you bring that, and then Mule offers a package for that. So you can install um, the runtime fabric on one of these three clusters, Kubernetes cluster, right? That these are there, and then the other option was, or is still there, is runtime fabric on a VM, right? I mean, let's say you have a situation where you don't want to go the nitty gritty, do the complexity of managing the complete Docker instance or the containers, or the cluster as such. The Mules does that for you, right? So and you can just that's just keeping, I mean, they're providing all the knowledge, or the complete responsibility of managing that cluster and everything, the internal workings of those pods, or internal workings of the containers, managing the clusters, everything. They're kind of abstracting out from, and then giving that off package solution, which is the runtime fabric on the VM, right? Where you don't have to worry about how things are working internally. It's already done for you. So that's the second option, right? Runtime fabric on the VMs or bare metal. And the good part of this is like you can just take it to anywhere you want. If you have something, let's say, you're running a different cloud platform, for example, IBM or an Oracle or something, right? And then maybe that would be a good fit for you. But again, if you look at this table right here, one is what we just what's the focus of today's topic is the self-managed Kubernetes, right? And then there is a bit of support line, I would say, who does what kind of thing, like what is to be done by an IT administrator, what is to be done by a MuleSoft org admin. Um, in a self-managed, right, you are bringing that MuleSoft is kind of being installed on that existing Kubernetes cluster, EKS, AKS, or GKE, right? So your job starts as a, when I say you as a MuleSoft org admin, right? Your job starts once the cluster is ready, it's perfectly fine, and it's made to your requirement, right? Then from then on, you just go and create a runtime fabric, deploys the applications, and you take it from that point onwards. You are not in the business of managing that EKS, AKS, GK cluster, right? That's the job of the IT admin. So whereas if you think of runtime fabric for on a VM bare metal, right? Because you are pretty much kind of, you're still doing the as a mule org admin, right? You're still creating a runtime fabric, deploying application, all that. But the only difference here is, um, like you are, I mean, you still have to know how to do this deploying and creating a runtime fabric. But again, the IT admin will take care of creating the infrastructure that runs the runtime fabric. Because at least the runtime fabric for the VMs, Mule is using a Gravity Kubernetes version. It's a different flavor of Kubernetes. It's called Gravity, and so that is already packaged within that product. So you don't have to know any nitty gritty about how Gravity works, how that flavor works. That's already done for you, and the IT admin will kind of create the infrastructure that runs the runtime fabric. But again, it's not a, you don't create a cluster there. When I mean, the IT admin also doesn't have to create a cluster, which is required by the self-managed Kubernetes, right? Like we'll shortly see that. What are the prerequisites for installing a self-managed Kubernetes? So these are the situation I was talking about. Like, what are the use case? When should I go for a self-managed Kubernetes? When should I go for a bare metal? So, as I discussed before, if you are an Azure shop or AWS shop or GCP shop, and you're already running that, and your team is pretty advanced in terms of using Docker and Kubernetes, then Mule just happens to be one of the candidate in your platform, right? It's and then you go ahead with your self-managed Kubernetes option. And people who are doing their transition journey for the for the second category of people where you are new to your IT team is relatively new to Docker Kubernetes, and but you still want to have the cloud hub like feature on your data center, and or there may be some kind of regulatory requirement. Let's say you are Macy's or JCPenney and all that, and then you are Amazon is your competition, right? For example, then you don't want to go to Amazon, or maybe for some reason you have a healthcare company, you don't want to go to public clouds for whatever reason, right? For HIPAA compliance or all that. If you have some concerns around it or due to some regulatory requirements, then you cannot use a public cloud. Then you can always look for runtime fabric on a bare metal or VMs. So what are the difference between these two flavors? Both of them supports deploying mules. Mule runtime and the API gateway. It's all anyway. It's all behind the scenes. It's all one runtime. And but for the Kubernetes Docker, when you go for a self-managed Kubernetes, so you need to for a self-managed Kubernetes runtime fabric version. So you bring your own Kubernetes cluster, right? And whereas for runtime fabric, as I mentioned just a short while ago, Mule will provide you that the whole package, which includes a gravity version of the Kubernetes. So it's a different flavor of Kubernetes. Um, so that's the difference. You on the second, you don't have an option to choose your Kubernetes flavor or a version when it comes to the runtime fabric on VM or bare metal. And when it comes to installing on any Linux distribution, I'm there you see Kubernetes because see one thing you need to know here, like when we talk about self-managed Kubernetes, you are depending on a lot of things which is already provided to you by this public cloud, right? Because when you are riding on a public cloud platform, AKS, EKS, or GKE, all that, right? So there are certain things which comes default by or provided by that public cloud. So you don't really have to worry about. That's not even a question, basically. Like installing on any Linux distribution, yes, supported, right? Because you don't choose that. I mean, you choose it, but again, um, it depends on what kind of versions are or Linux versions are offered by that public cloud. Based on that, again, so I'll keep my focus towards the self-managed Kubernetes. And so we see the node auto-scaling. So that's a big feature. Um, Again, the node auto-scaling is not a feature of Mule, right? It's a feature of your public cloud. All these three, AWS, Azure, and Google Cloud, right? It's their feature, right? So it supports, as we know already. Whereas um, the runtime fabric on VM bare metal, that's not being supported. Node auto-scaling is not supported by the runtime fabric on VM bare metal. And external log forwarding, it's a big topic, but again, you should provide your own log forwarding service. If you will talk more, if you have a Titanium subscription, you do that with your Anypoint monitoring for the logs, or simply use your CloudWatch. Or there's a lot of, again, it's being you're being a using or you kind of leveraging the features of a public cloud. You get a lot of option when it comes to log forward. You just use whatever is available to you, or you do external log forwarding using Splunk and all that. There's a lot of choice there. For internal load balancer, this is a bit tricky one, and we'll talk what exactly is that. So it's kind of a think of this way, like think of this like a lightweight gateway, which does some basic traffic routing, security, mostly internal. Uh, so, uh, so you should bring your own internal load balancer, which is also called ingress controller. And there's some difference when it comes to Google Cloud um, and Anypoint Security Edge. That's the security solution by Mule, right? I mean, not supported here in case of a self-managed Kubernetes because there are many ways you can secure your edge, which is supported out of the box by the public cloud. So this will be a redundant solution when you want to do this. So it's not really required. in this scenario. And Op Center, again, Op Center is a terminology from the runtime fabric on VM. That's something to do with the Gravity VM. Uh, I mean, the Gravity flavor of the Kubernetes, right? That's not relevant for self-managed Kubernetes. And if you want to do some monitoring, yes, a lot of things which is already available to you by the public clouds. You can do Azure Monitor, CloudWatch, and all that good stuff you can leverage. Plus, you can also use Anypoint monitoring. Any questions so far before I move? Nope. Okay. So take a look of this diagram.
Sorry, Mani. I think there are a couple of questions.
Yeah, you can read it.
Yeah.
Oh,
Are the
yeah.
self-managed Kubernetes offering limited to those three platforms, AWS, GCP, Azure, or could it
Yes,
do on
that's
a digital ocean?
at this as of this time, or as of now, this is the only three supported public cloud offerings. There are no others yet.
Yeah. No, I think that's all for now.
Yeah, that's what I was saying. No, if you are running on Oracle Cloud, right, um, or IBM, then yeah, definitely. I mean, you may want to look for runtime fabric, the bare metal one or the VM one. So, I mean, the same thing basically. So if I so take a look at this slides, I mean, you guys are using MuleSoft for a while. So one thing you will notice here, um, right? See, this is just like a typical, cluster. If I replace this diagram with a cluster or EKS, AKS cluster, it will be pretty much the same. Now you have nodes, and then the nodes has pods, and then the pods are running. In this case, Mule runtime engines, Mule applications is all just like with any clustered, like a Kubernetes cluster. So your applications are closely bundled with the runtime engine, right? And that's a pod running up here inside of a node. You can have multiple pods in a node, and there is another node. There's another node, and these all nodes are connected through a network. But one unique thing, what you see here is a cross-cutting thing. Each of You see there is a runtime fabric service, so that is new. That's kind of running across all these nodes. Basically, it's running as a cluster resource, which is spanning across all the services. I mean, all the nodes. So that is think of that way. Think of this way, like a kind of an agent-based system. Your agents are running in all the nodes, and they're kind of sending all the. They're kind of your, I would say, the connecting platform, right, between all your nodes, which is talking to the cluster controllers, and then that's how everything is. All the magics are happening because this is running across all the nodes. It's pretty much like a cluster resource, which is common across all the nodes. And what you see, there's two split here. What is managed by MuleSoft, what is managed by a K8, I mean Kubernetes specialist. um, th- because you bring your own cluster, right? There's EKS, AKS, and GKE. So that's the responsibility of the cloud admin to commission or provision that cluster, and you tell them, okay, you need this many nodes. You define the requirement, and then they will do that for you, right? And what is managed by MuleSoft? When I say it's like managed by the MuleSoft org admin, are things which are your yeah. So that's okay. So you pretty much are responsible for creating the runtime fabric, deploying an application. So anything like star mule star is your responsibility as an org admin, right? And um, so that's the big difference. And this is when you are kind of creating one. When things goes bad, then you'll come back to this diagram, right? So then we all know when running an enterprise, we have clear or maybe like a dotted lines when it comes to responsibility. Um, so when something goes wrong and then people start pointing fingers, then oh, is it a mule issue or is it a cluster issue? That's where what I was showing before, because you remember this, you're running on a cluster, right? And you're not the only candidate or riding on that cluster, right? There will be many of such applications, right? There'll be different teams running. I mean, on an well, in a runtime fabric cluster, you can only run runtime fabric stuff. You cannot do any other non-runtime fabric or non-mule applications. So that is pretty limited um, within that the cluster you're going to create. But again, it'll be good to know who to reach out to if something goes wrong, right? When that we'll talk more during the monitoring and support kind of like when an issue happens, where do I go, where do I start, and then who should be assigned for fixing what kind of issues. Like um, so that's where you should have that clear lineup separation of duties here. If you see there is something going wrong with the cluster, if the cluster solutions telling you something with the resources of the CPU, memory, or the node set, node pool, all that, then you know who to talk to. If it's going inside something wrong inside of your applications or within your Mule runtime, then definitely you will be in charge. So these kind of things will help to quickly troubleshoot and find out. So basically, the what I'm trying to say here is, so the sooner you find out what is happening, and then the quicker you can fix that issue, and that's true for all. But again, in a clustered environment, that things makes more more, that has more importance, right? Like whether quickly finding that out and assigning the team who are responsible for it. Yeah, we just talked about it, so I'll just quickly talk what does a customer manage in the sense, like like the cloud admin in this case. um, So the ingress controller, that is something I was briefly talking about. It's think of that as like a lighter weight gateway, which does your internal traffic routing, security, and all that stuff. So that's to be done or managed by the customer. So let's say you are using a version which has to be in sync with the Mule software, Mule runtime, because these things keeps changing, right? I mean, you now think of, you have your cluster has its own versions that will be upgraded. You need to see your Mule runtime also gets regular updates, right? So you need to see that compatibility metrics, and then once that when the time come, who should do upgrade of what component. This slide will help you. Ingress control is a responsibility of the customer. When I say that's a cloud admin, and any logs, metrics of that cluster, again, it's your responsibility of the cloud admin. All this, CRI, CNIs are basically your network interfaces, and um, all those cluster related interfaces. Um, be it your storage interface or a network interface, node pools, all that is, it's all the cluster admin's responsibility. The cloud admin's responsibility basically. And all the blue stuff is all Mule, which is, you guys are responsible for it. Okay, any question? So that's all I will talk, and the remaining stuff we will talk as we go through, and we'll talk about. So in for the remaining time, this is what we're going to do. I mean, we'll I mean, we need to create an AKS cluster, but I have already done that because it takes a while. But the typical first step is I create an AKS cluster, and then we'll install a runtime fabric on an AKS cluster, what we just created. And the critical part is configuring ingress controller. So in this scenario, right, because I'm wearing both the hats here, right? I'm showing a demo to you, so I'm doing all the things. Um, but ideally, number two is the responsibility of the Mule org admin, and configuring ingress controller and all that is the job of the cloud admin. And then we'll deploy a Mule application. So, and And you will appreciate how these are made very simple for by Mule to kind of quickly get started on that. And we'll, typically, these 7 steps uh, typically which will take a should take a day or so, right? If you but you'll learn soon that these are pretty easy, very simple. Won't take much time, and we can do all of that. The installation just happens to be a just few commands, and your installation is done. Won't even take much time. But the critical part here is configuring that ingress controller. And we'll deploy a Mule application, just a basic sample hello world application, and then we will focus on the security because we are configuring an ingress controller, and we will see how that ingress controller plays in action, and then we'll see how do we secure the traffic from a client to the ingress and from the ingress to the backend API. So this is what we're going to do. So ignore for a while this Azure load balancer in between. What you see here is a client apps, and towards the right is your AKS, Azure Kubernetes service, and we'll do all that. And we'll this N is stands for Nginx, which is an ingress controller. We're going to use that, and all the pods is where we'll be deploying our applications. So that's running as a pod, and yeah, that's all pretty much we'll do. And then this logs security, what you see here, we're securing 2 traffics here, one between the client apps to the ingress controller, and second one is from the ingress controller to the MuleSoft pod. So that will completely do a complete end-to-end security, the securing the traffic. Any question?
Mani, I think there are a couple of questions. So Mohan was asking what is CRI and CNI stands for.
It's a container runtime interface, which is an Kubernetes internal. I think CNI is for the network.
Okay.
So when you install a Kubernetes cluster, it has its own runtime. It has its network. There is also a storage CSI. It is all internal functions of clusters.
Okay. And the next question is from Amit Arora. On which situations we should go with RTF? That's his first question. And the second question is how to measure which one will give good performance on which scenarios, RTF with Azure or RTF with bare metal.
Okay, so I'll take the first one. Which situation we should go with RTF, right? So now you want to, let's say, you're depends which situation you are in for currently. Let's say you are I mean, you are doing Mule very recently, and then you are doing a MuleSoft, I mean Mule runtime on-prem, right? And where you have running, let's say, 30 40 applications and all 2 by 4 configurations, and just doing a traditional Mule, what the way you're doing it. And should you, I mean, if you want to go, let's say, many of our clients, I would say, also using on-prem with the cloud hub option. They have both. It's kind of a hybrid cloud platform. And to answer your question on what situation we should go for our RTF, is like you want more control, right? MuleSoft will do it for you, right? And licensing doesn't really matter because you pay the licensing wise the same. You pay the same amount of, per year or the subscription based on your 2 by 4 configuration, right? The only catch here is like, and you know, if you're a Azure shop, if you are in a AWS shop, let's say you pretty much many of the um, you know, MuleSoft happens to be a part, like quote unquote, of your overall cloud digital migration or a cloud journey, right? It's not the destination, right? So you don't. It enables you makes things quicker and faster. Let's say you're running a lot of your applications in Azure. Your you know let's say you have your Azure data, how your data warehouse is running in Azure. You have moved a lot of core systems, like Java based applications to Azure. So you're doing pretty much with Azure, and you're also doing Mule today on prem, right? And then there may be a time which You cannot run once your all your core systems has already moved to Azure. There is no point running Mule on-prem, right? Will it be? It's like you're building a garage in the third floor, right? You cannot do that. Right? It has to be on the same floor where the cars are coming in easy to get in and get out. So, so if everything in Azure, everything in AWS, and you're already mature in your cloud journey, right? And you're also doing Mule, it makes sense to leverage the RTF for the using the RTF with the self-managed Kubernetes. And does that answer your question? I mean, you can type if it is. And the second question is like how to measure. So performance is very subjective, right? I mean, you need to do. I cannot really say this is faster or this is not like a ticker price. I cannot tell you this is like a plain black and white, right? I mean, depends on various factors, and you really have to run your Azure um, or like you really have to do a performance benchmarking. So, but in general, it's really not. You don't go to Azure or a RTF on Azure or RTF on bare metal because of the performance. Your performance really matters, but again, when you really you think of what are the factors for performance, right? You need to have your cluster has to be healthier, right? I mean, it should be able to take up your uh, because Mule again happens to be part of that cluster, not the cluster, right? You're running a Kubernetes version, so the many things will shift towards when you say RTF with bare metal, it comes with the gravity flavor, and then it's already performance benchmarked, and then number of it depends like number of CPUs you're throwing at the cluster, number of nodes you're throwing at the cluster. There are a lot of variables. I really have to do a benchmarking with a bare metal versus Azure, so to really get to a performance result.
Uh,
And Sergey is saying the Gravity project is no longer under active development. Yes. Um, yeah, that's a good point. I don't have the answer for that, but that's what MuleSoft, the RTA version for the bare metal is packaged with. I don't know what kind of support agreement or like yeah, I don't know that internal to answer your question. Like, if the Gravity is no longer under active development, who is managing? I guess Mule is managing because that's what it's running on. But yeah, I don't have a right answer for this question.
Mm, Mani, I do have a question on some different topic that is like how
Sure, go
do
ahead.
I should go with currently suppose my organization is using Cloud Hub. What kind of mm, advantage I will get if I will move to RTF?
See, first of all, Mule doesn't restrict you to do this or that. Your
Hmm.
licensing is fixed 2 by 4. Two development, four production is a baseline, but again, you might have more. But again, it's like you kind of port your license anywhere you want. It doesn't matter. You can do on-prem. I have seen many implementation where they have all three,
Hmm.
and and the very different scenarios they're using them for. Like one LOB is doing all Cloud Hub, one LOB is doing all Azure because that's how everything is running in Azure. So I mean, it's the question about do I need to move?
Yeah.
Because the, and then the question you'll be asking yourself or
Hmm.
within the organization, right?
Hmm.
I mean, from a the Cloud Hubs, you get a lesser compacted application, like a less density of application when you go to Cloud Hub. That means like you can only run 10 application in a Cloud Hub, right?
Hmm.
Per core,
Hmm.
10 or 20, I think. Same thing also carries over to Azure. So there is no difference in there because you wanted an application isolation, you got it
Hmm.
using a Cloud Hub or RTF on Kubernetes. Same thing, right?
Hmm. Hmm.
It's more of can I have my do I want to manage like do I have to worry about too many tools? Like if everything is running on Azure, why
Hmm.
to again manage everything in like why to have someone else like being managing my Cloud Hub stuff? Like like it will be simplicity of operation, one example. And again, you may think I would like to have more control in my clusters, right? Because you want to have more control over your Kubernetes cluster. And again, the whole point is like if you're already running in Azure, right?
Mm-hmm. Mm-hmm.
It's not like you're not using Azure or AWS or GKE, right?
Mm-hmm.
And
Mm-hmm.
you're already happy with Cloud Hub, be there, be happy there. You don't have to come to because Cloud Hub equals to RTF in terms of
Okay.
the architecture, right?
Mm-hmm.
It's the part which is difference is whether you want more control over your cluster or you want to give it away to MuleSoft. That's the only difference.
Okay. D-
And
Uh,
or
do we get like fractional core availability in RTF? Like we do have a restriction
yeah,
like
yeah,
point
you
one,
do get
point two.
you get it
Okay. Okay.
because
Yeah.
it's again it's not a feature of Mule. It's a feature of the cluster.
Yeah.
The
Yeah.
cluster, the way you deploy an application with a fractional core, like
Mm-hmm.
that's the first. I mean, it comes out of the box using a cluster, Kubernetes
Mm-hmm.
cluster. You can
Mm-hmm.
split your cores as you want.
Oh, okay. Okay.
So it's
Yeah.
the same thing. You will see shortly that really there is no difference when I talk about it's about I'm a Azure shop. Do I want to leave my integration in Cloud Hub? I have done many projects where prior to this offering, I won't name the client, but again, it's a healthcare client. We have to set up a VP. They're running Cloud Hub,
Mm-hmm.
and then they were running everything in Amazon, right? Now we
Mm-hmm.
have to do a VPC peering,
Yeah. Yeah.
VPC peering between AWS and Cloud Hub,
Cloud Hub. Yes.
right? Because it's all behind the scene is all one VPC because
Mm-hmm.
it's all Cloud Hub is AWS and running Amazon. So we have to do that.
Yeah.
When there are other clients who are doing Azure, we have to put a VPN network between these two.
Yeah. Yeah. Yeah.
Right now you don't need that. Like if I go back, if I do a time travel, I would say
Mm-hmm.
you don't need to do that, right?
Mm-hmm.
You do the self-managed Kubernetes. It's all comes within your platform. So think of this way: the Mule is evolving, or kind of the way the customers are evolving, or a bit ahead. Mule is a bit ahead of what customer will do,
Mm-hmm.
in because if everyone is doing Azure,
Mm-hmm.
if your organization is powered by Azure,
Mm-hmm.
you don't want Mule to be outside of that
Yeah.
running in. It doesn't make sense, right? Then you
True.
have to have
True.
all this network latency between going in, going. You'll pay for ingress, egress, and all that headache will come, right? You don't
Yeah.
want to do that. Just bring it out, bring it all in, right?
Mm-hmm.
Makes
Mm-hmm.
life easier. You save money, cost, and all that, and then you don't have to deal with two different platforms, right? So it
Yeah.
makes more sense.
Yeah.
So again, so these are the points you should really think about. Like,
Okay.
um,
Yeah. Thanks. Thanks, Mani, for all the
yeah.
insights. Yeah.
Okay, so let's head back to the demo. So first thing for the demo, we need to create a cluster, right? Which I have already done. So I'll just quickly. Okay, so my cluster is already created. So I won't because cluster takes 15 minutes. So what I've done, create a resource. There are many ways. Either you go do visually like what I'm doing, click Kubernetes service, and then fill up all that stuff. And just like with any other public cloud, you need to create a resource group first. A resource group is think of that like in a container, right? Where you or like a house you're building basically, right? Or like right. So you put everything first. You build a house, and then you start packaging stuff inside in different rooms. So think of resource group as a house. So you are creating a cluster in this resource group. So I have already done that. So I have created a resource group here, or you can just create a new resource group, and then that will take you. So you can do many ways. So first create a resource group, then create a Kubernetes cluster. And while you create that, one thing I would like to show you to name whatever you want to, and then we are creating in region East US, and the version. See here, there are so many versions here: 123.5, 123.3, 22. But as we speak, I'm going to show a demo of Runtime Fabric version 1.12. So, and according to the documentation, like typically, we start doing things without referring the documentation. Right? That's what I did when I tried first time. Then I just directly did things. Then I realized then thing didn't work out. Then I realized what didn't work out. Then I just selected the latest version out of this, and then got an error. It didn't work out. It took me a while. Then I went back to the documentation to see why it didn't work, because I was selecting all these non-supported versions. Even though you see all the greatest latest versions here, it is not supported when it comes to Runtime Fabric 1.12. So there is a compatibility matrix between what Runtime Fabric versions is available and what is it compatible with the Kubernetes version. So today we'll be doing Runtime Fabric 1.12, which is the latest. Um, and it's supported only with 1.21. Um, dot x, that x is version 3 or higher. There is no 3 here, so it starts with 7. So I have two options, 7 or 9. I'll just go with the version 7. Um, and if you see here, standard DS2, these are like a pre-packaged options. DS2 V2 will, it has certain number of, if you see here, we're going the D series and D series DS2 V2. You can pick and choose anything you want. It's not a um, deal breaker here. So, and for the command for that, so I have already copied that command. So the first thing we will do is do this. I've already done. So you create app. This is I'm using a. So yeah, one thing I missed to tell you. There are a few things you need to do before you get started. So you need to get a Anypoint platform. You can always sign up for a free trial account and get an Azure CLI. We'll be doing a lot from our command line. So you can just Google Azure CLI, and there are steps to do that. And then we need, because we are operating on a Kubernetes cluster, so we will be using kubectl. Kubectl is a command line tool for working with Kubernetes cluster. Then we need a runtime fabric control CTL, RTF CTL is a command line tool to locally manage runtime fabrics. And last, you don't need it. It's a call command just to test the APIs, or you can use Postman or anything. So I've already done these steps. I'll just take you straight away to. Yeah, I was showing you create a resource group. That's the first thing you ever create in a public cloud. The very first thing, you cannot do anything without it. And this command here is kind of creating a Kubernetes cluster. If you see AKS, as your Kubernetes service, create resource group, I've already selected in the previous step, RG MuleSoft RTF demo, and name of my cluster is AKS MuleSoft RTF, and I'm selecting 2 nodes. So this is critical, and we'll see. I talked about node auto scaling, right? This is my starting point, node count 2. And that's part of the cluster. You can always in runtime, you can always scale up, scale down. And see, I'm supplying here a Kubernetes version 121.7, and my VM size, which is I'm selecting a DS2 V2 series, and which is a prepackaged. Uh, it's a prepackaged thing with it has some 7 gig of memory. Um, it has, I mean, it is a 7 gig memory, and then dual core CPU. It comes with that. So again, it's not a, you can choose anything you want basically. So with that, the cluster will be created. I'm already created that. I'll just show you the cluster created 2 days ago. It takes somewhere around 15 minutes, 10 to 15 minutes. So if you see, this is the resource group. We have one node pool, and that node pool is basically has 2 machines, 2 nodes. You see 2 nodes here, right? And I have selected manual scaling. You can always select auto scale. And then again, these are a feature of the cluster, not a feature of Mu. So you can play with this if you need. And then this is what I was talking. DS to V2 is like 4 vCPU and 14 gig. So the reason I'm saying focusing on ports, because remember this is where your licensing is counted towards. So you should be careful about which series you're selecting here. So this is 4 VC. So that's pretty much your. Um, I mean, if you have a 2 by 4, this is already licensing is already done. So you may need additional license for it if you go beyond 4. Anyway, so that's about the cluster. And the first thing we will do is now you create a resource group, you created a cluster, and then we need to get the credentials. Okay, I'll just copy this because remember you just got your you created a cluster, right? You have configured your Azure CLI, AZ CLI, right? And um, okay, so we will get the credential. So getting a credential will kind of will store or cache that credential in your local this machine, so that going forward, you don't have to do that AZ login. So it's kind of caching in your credentials. So it created a .cube config file in your. So it's kind of caching that in, and then we'll because since I've already created the cluster, let's see the nodes. Right, we have. So right now we have a clean slate, right? We have 2 nodes, and they're all running version 1.21.7 of Kubernetes. So the node pool concept is kind of you can add like these are concept of the Kubernetes cluster or AKS cluster. So assigning a node pool, you can have any number of nodes in that node pool. So it will be easy for auto scaling of the nodes. Okay, so now let's head back to runtime manager, because that's where we will install our runtime fabric. So head to runtime manager and so click on runtime fabrics. So I'm going to create a runtime fabric inside of dev environment, and once you create it, you're pretty you can always assign the same runtime fabric to multiple environments. Um, but ideally, you should keep it separate between dev and prod. So if you see here, when you click create runtime fabric, you are given many options here. The top 3 are the Kubernetes flavor. Either you do AKS, sorry, I mean EKS, or Azure Kubernetes Service or GKE. So you have 3 options for Kubernetes, and then the last one is your VM bare metal. So we are going to select a Kubernetes flavor for Azure. And again, this I have talked many times, so you read one more time who is doing what basically. So, so the separation of duty between your IT department versus your mule admin. Oh, oops, okay, I haven't deleted that from the last. Just delete. Just a second. Fix that. after after hours and kids being home. That's a common noise. Okay, so your next accept. Okay, here now again these steps are common between a runtime fabric on a bare metal and versus self-managed Kubernetes. You get a activation code and copy that, and now once you keep that with you because that's what you're going to use to install or activate. So the second thing, um, I mean the next thing we will do is remember we already have a cluster set up, right? And we have already cached in all the configuration. So and then we also have runtime fabric CTL installed, and now we just created a runtime fabric within the runtime manager. We got an activation code. Now we need to link these two. We're linking uh, the management plane of the runtime manager, right? Remember that's running in AWS. The Cloud Hub runs on AWS. That's your management plane. Maybe I have not shown you. There's one more slide. Yeah, I don't have it here. Just know that your runtime manager runs on and that's a control plane and runs on that's pretty much runs on AWS. And now this one, what we're creating, the runtime fabric, we're creating inside of AKS, right? So they need to talk to each other, right? So we'll and before we proceed with the installation, we need to validate. Like we need to validate if everything, if the cluster is ready, it has all the connectivity, it can talk to the control plane. All that part is part of the validations. If the Kubernetes environment is running, all the services are available inside of that cluster. So it does all that, and you paste that activation code. It's going to check. You see all the tick marks to the right? That means these are all good. It's checking the CPU capacity, memory, all that. And this is what I was talking. All this worker, cloud, ham, prod, S3. These are the uh, the control plane of MuleSoft. So don't get scared. Like, oh, did I select Azure or AWS, right? Because you did select Azure. These are the control plane of MuleSoft. Okay, so all validations successful. So and make a note. So we just started barely a minute. Just now we started basically like 30 seconds back. All we got created a runtime fabric and see how quick. So we just validate. You did a validation, and now we're going to install. CTL install. Okay. Okay, so it's still waiting for the runtime fabric to become ready. And so let's go back and see how it looks. So you see here, where did it go? Yeah, see the ready for activation, the last one. So look at the version here, 112.28. And if you see, so the two things, I think someone else was doing a demo. So you see there's appliance, the distribution, it says appliance versus AKS, EKS, GK. So the appliance is the last option, the VM bare metal. So it's still, and just to take you back, so what is happening here? this Kubernetes runtime fabric is being installed, right? And this agent, which is a cross-cutting, which I was showing up you here, this cross-cutting service, runtime fabric services, right? They are now trying to connect to, so that's a service which run across. It runs inside the cluster. Now it's trying to connect to this website here, which is your control plane. So that's where it's taking. Oh, it's done. It's registered. But the status is ready for activation to register, but still not active. I mean, it takes a while. Yeah, it says it's ready. Um,
Mani, meanwhile, there was a question from Sergey. He was asking, how are you monitor vCore consumption for RTF AKS clusters?
I mean, yeah. So that's you do your Azure monitor. Again, see, this is like think of this way. The thing this is like any other application running inside a cluster. The way you monitor your cluster usage, you do the same way. I mean, now if you go to here and then go to this, so basically use the existing cluster monitoring tools.
Okay, so the one that is already built in
Yeah, it's already built
Azure.
in. Yeah,
Okay.
because because you are this is a managed cluster, right? It's
Mhm.
not the cluster you are you Azure is managing this cluster, right? I mean,
Yeah,
it has all the tools. You're
yeah,
commissioning, you're leveraging a software, I mean, platform as a service, right? Kubernetes, a
yeah.
platform as a service, right? So Azure provides you all the things. There are many, yeah. See the whole bunch of monitoring here. You can measure here, insights, metrics, and you can deep go. There is a see the CPU utilization here, and then you can deep dive. It has all the tools out of the box: nodes, uh, containers.
Yeah. So, like, is there anything specific to like checking the how many cores is being utilized?
You have selected four cores, right? Four vCPU.
Oh,
So,
okay.
right, that's your default. I mean, that's what you have selected in your cluster configurations.
Hmm.
So within that core, how many CPU percentage you're using is what that's the question you need to see. Am I hitting? Um, because you have selected that many cores to start with, right?
Yeah, yeah.
And then
Okay.
it's all about how much you're using that core. If you see
Mhm.
here, it's 99 CPU usage here. This is what I was saying. CPU usage millisecond and all that. So
Oh, okay. Yeah.
average to that four cores.
Okay. Okay. Yeah. Thank you.
And okay, so what I was doing is, yeah, let's check back. Now you see the status has changed to active. It was registered, ready for activation, then registered, then now it's active. So it took a while, maybe like 2 3 minutes. Which is all done. The next thing is we need to just do a quick verification RTFCTL because the command for verifying your status of the well, there are a few commands which are these are runtime fabric commands which is same across your appliance version, which is the VM bare metal, all also the Kubernetes one. Now, so I want you to focus one thing. It's a lot of information, but take a look this one. So you see the role is agent, right? I mean, we know the name of the this is the node details here, and his role is agent, healthy, true, role agent. So these two are the agents. These are both the nodes inside of that node pool. And look at the component runtime. So this is the cluster information, and then here is the RTF information here. So you see this agent is true. So this is the agent which is the cross-cutting one with this middle line here, right? Which is running. It's an agent-based architecture here. That agent is running across all these nodes, and so that is healthy. And you have a cluster IP service that's kind of provides you the IP address of the cluster, and there's some resource cache. So three things are the components of a runtime fabric. And other than that, these are all connectivity to the control plane and is a certificate. That's all pretty much. Case, DNS check, all that. So our cluster is healthy, and now we need to apply the license. So to do that, you already have your license, right? Your demo license. What am I typing? So do RTFCTL apply new hyphen license, and in this case you'll be applying your base 64 license. So base 64 license. Don't do that license.lic. You need to base 64 encode it, and you can head back to um, your Unix, and then type the command for like base 64. If you let's say you have your license file, right, you do base 64 encoding license.lic. I mean, I won't hit the enter button, but this is how you do it basically. um, so it'll give you a encoded version. So I'll quickly stop sharing, and then I'll apply the license. Can you guys hear me?
Yes, yes, Mani, we can.
Pinku, I have a meeting now. Okay. Just okay. So anyway, so I think I stopped sharing. Yeah, I did share. Okay, let me apply the license quickly. Okay, I have applied the license. Let me share my screen. So this is our partner license, so that's why I'm kind of stopping sharing. Okay, the license is updated, and so now let's head back to the runtime manager. So let's look at the configuration of this runtime fabric. You see, is all systems are healthy, um, and we have not associated this with any of the environments. I'm going to select dev and apply allocation. You can pretty much share this across non-production versus production. Okay, so now you see this inbound traffic here, right? So we just deployed and deployed this runtime fabric, right? Provisioned this runtime fabric cluster. So now, before even I go ahead and do it, the deploy an application, it's saying that you cannot manage endpoint for apps deployed to this runtime fabric because ingress has not been configured. Like, think of this way, right? So you're going to deploy an application, right? And that application is going to be exposed, right? And but how do you expose that? Because you need an endpoint, right? So that a REST API call can be done. So for to enable an endpoint, so you need to configure that in the inbound traffic, which is done through this ingress controller, This, you see this ingress word here. So that's for communicating to the outside world using that ingress controller. So this is pretty much. So will be deploying and configuring an ingress controller. So this piece basically, like see the N here. So our AKs from this, so far we have done this AKs cluster. You see this M mule stuff here. That's a like I should kind of draw another line here saying this is the runtime fabric, but this is running as a pod. So it's not a cluster inside cluster. So it's your AKS cluster, and then all you have is various pods. So if you want to see what are the pods running, I'll show quickly. But again, all this M stuff are done pretty much. Well, all the M stuff excluding the application. So this is the M stands for here is for the Kubernetes runtime, whatever we have installed so far. So it's half done, I would say, and then we need to deploy. Um, we need to deploy that applications inside of these pods. And then before we even deploy an application, we need to first fix this or create an ingress controller, because we'll be testing it from now. We'll be doing a hello world application, and we'll be testing from outside from basically from my laptop, right, from an external client. So we need to have this ingress controller provisioned here. Okay, so the way to get that, and so ingress controller is basically a lightweight uh, traffic routing mechanism, or like a piece of software used for traffic routing, securities and all that, um, like an HA proxy kind of thing. And so we need to get this ingress. There are many ingress controllers ever. It's a generic name, quote unquote, ingress controller. You have many choices when it comes to getting an ingress control. So either you can go for Nginx, or what I'm using today is like an ingress controller. I mean, Nginx ingress controller supported by the Kubernetes community. It's open source Kubernetes community supported Nginx control, basically. There is something which is given by you from Nginx as a company, and or you can get a community version from Kubernetes. So I'm just using community version from Kubernetes. So for that, um, we will be deploying this, right? First step is, so in Kubernetes world, the way you apply, the way you deploy things are just getting that YAML file and applying that configuration. That's all. So kubectl apply, and then whatever YAML file is that. So what we need to do is get this. So this is basically, if you look at this, so this is the ingress controllers YAML file. And if you see, it's getting it from raw GitHub user content Kubernetes, because it's from Kubernetes community, and ingress Nginx. Again, as I said, you have many choices. You can bring your own. I mean, you can just use any ingress controller. I'm using Nginx by the community. And this deploy YAML looks something. Yeah, this one. So if we just go and paste it, just want to show you how that looks like. So this is the YAML file, and it's a pretty it's a deploy, right? It's a pretty big. It's just kind. It's basically creating a complete resource inside of your Kubernetes cluster. So it's a huge one. So all we have to do is get this and apply. I mean, you don't have to. Just simply it will download automatically. Missed the F command. So it has created that ingress controller, or like installed. But now we need to configure that. So now if you see, now we need to configure that template, right? So um, I'll open up that. So we installed a Ingress Nginx Ingress controller, and we'll be configuring that. So this is a configuration. So in Kubernetes world, as you know, this is all YAML configuration files. You have to get that and then just deploy or configure all that based on this YAML files. So if you see here, this YAML file, the kind is an ingress. So what kind of resource we're talking here? We're talking about an ingress resource, and see all these annotations here. So it has a specific rewrite one. It's doing some URL rewriting of this. It's rewriting that app name and replacing that. Um, it's doing some URL rewriting basically. And so this is a critical component. Namespace is RTF. So in a Kubernetes clusters, right? So your namespace is you know, plays a big role. Um, you know, and the way runtime fabric is being provisioned here, it talks to um, any runtime fabric components has a common namespace, or like they communicate with each other using an RTF namespace. Like anything with a RTF hyphen or RTF is how the agent communicates with these resources. So it has to be prefixed with RTF. So that's how the agent recognizes this and then starts communicating with that resource. So this ingress template, even though it's not a it's not a mule supplied or runtime fabric component. This is a customer responsibility, right? But you really have to change the namespace to RTF so that our agent will start communicating with this template automatically. So we just have to give this namespace as RTF. And same thing with ingress class name, we have to prefix with RTF hyphen blah blah blah, doesn't matter. But again, it has to be RTF hyphen. And we have the host name I'm specifying here is rtf.example.com, and there are some placeholders. I mean, there's a lot of details when it comes to placeholders, but just learn that this is a placeholder. It's anytime you deploy an application, like Hello World is your app name, right? So we'll soon learn that this will be replaced by that Hello World, and these are for not really being referenced or used by the agent, I would say. So this is a very basic runtime fabric template, clean slate, just 21 lines, and now we will be kind of enhancing it and adding more features to it. So let's apply this template. Kubectl apply f, and let's see effort in this template. Okay, so we provisioned this. Now see what change has been done. Remember, I told this has to be prefixed with an RTF hyphen, right? That's how the agent connects to this. And now you see here, it's already, I didn't even refresh anything. That message is gone. And now you see here, as a base endpoint is showing us. Now we enabled this component, and it's kind of displayed up here. The agent has recognized that external component, Nginx, and made a connection to that, and kind of so it's configured basically. Now you can start using this, and this is the host name we gave, rtf.example.com, right? And then the unique part about this customizing this ingress template is, right, you can do many things. You can add multiple ingress configurations per application. You can, like, if I have to, like, this is a base one, right? This is a base endpoint, just like typical in Mule application, right? We put a star hyphen API, sorry, a slash API forward slash API, right? That's your base endpoint, right? Then you can add any number of endpoint, like actual URI, I mean, or like actual path after that base endpoint, right? You, let's say you have an API which does your insurance API you're making it, right? So let's say code like slash API is your base endpoint, and then after that you do a slash code slash get members, like not a like a member, you do a get on it. So all that will be different resources will be suffixed after this base endpoint. So you can add as many as endpoints for that application. But that's application specific endpoint. This is I'm talking about a base endpoint. These two are two different things. Okay, so log forwarding, yeah, it's I don't have a titanium subscription. If you have, then it will show up. Just have to click, easy, simple. Or you use leverage internal features from Azure to do log monitoring, or leverage a Splunk if you want to externalize that log to a different dashboard. There's a lot of choices there. So let's start deploying an application. So we will deploy an application, and Amit, you were asking before, right? Um, how is it different than a cloud hub? You'll see. Let me just name that application name as Hello World. Place date is 0421 deployment target. If I select Cloud Hub, see what you get a fraction core. That's what you're asking. You get a fraction core, right? And here you have the option to select the regions, right? I mean, because I already, in my case, I've already selected a US East, my region of my cluster, right? So I won't see that option here. When I select change this to runtime fabric, and all other good stuff here, which comes with a cloud hub, is your runtime. What is that rolling deployment? Anyway, so if I choose RTF, see the same stuff here pretty much. You see the same. You have an option to select multiple runtime versions, right? Um, and you have the option to select replicas, which is like a number of worker in the previous screen. If I select here, I see this the worker size and workers, right? It's similar to what you have the replicas, basically. How many workers you want to spin up, like how many. Oops, my bad. Like how many copies of that application you want to run. So that's your replicas here. So you can select 8 up to. So I'm just selecting 2 here, and yeah, I'm keeping many things default, and the deployment model is rolling update, right? Just typical with a, and then you have your CPU fraction core you can allocate. I'm doing a hello world. I really don't need to waste CPU. Remember, I have a 4 vCPU as a max, so I'm just doing a reserved and a CPU limit, and the basic memory whatever is given here. So I have a way to burst into the max. So whenever, um, okay, so I'm getting a hello world file. I'm importing from the exchange. Getting the standard. Because our aim is to show the runtime fabric. Right? I'm just getting a basic simple application from the exchange directly and deploy the application. One thing you will notice here. So let's while this is doing, I would like to show you how things are changing. You got to get pods, and I'm using all namespaces. I mean, so if you see here, the pods are initializing. This is my hello world application here, right? It's a 0 of 2 pods are initializing. And remember, I have two replicas. Still pods initializing. Now it's 1 of 2 running here. 1 of 2 running still. Just like what you, oops, yeah. So it's started. So your two pods basically, and both are 2 of 2 running. Okay, so now it's running. The two replicas started, and look at what happened. So if you just reference here, we have this path as app name, right? So this app name is a placeholder. So basically, this is our hello world is the application that we are running, right? And to see here, so this is showing up here in your application URL. This is the application name. So this is basically your path for, it kind of rewrites, I mean, it kind of appends that URL in your application URL. Like http rtf.example.com is your host name. I mean, it won't be like this. In your organization, you need to put your own. You need to work with a cloud admin or network admin, and then get a DNS here, and then slash your application name, or you have you want to have a base endpoint, insert that, and then your application. And you can do many ways your endpoint, however you want. Um, so this is what I was saying. So if you see this ingress, what I was showing you inside of the runtime fabric was the base endpoint, right? And now these are the application specific endpoints, two different things. So the beauty of getting a custom ingress resource is like you can have multiple ingress configuration per application. Now, if you see here, I can add one more. I need to change this, but I can see path here, and you can add a different kind of path here, and then click add endpoint, have another name. You can customize that, so you can keep on adding as many endpoints for this application. So just close it for now. So it allows you to add multiple endpoints basically. I'm just keeping it simple here, so having one endpoint. Okay, so that's all. So this application is deployed. So we'll just do a quick test, and I have a cheat sheet for that. Well, before this, can we ping this? This rtfexample.com is one thing we need to. If I do this, I cannot, because see, remember, rtfexample.com is not a public. I cannot do a ping on this, right? This is a private. It cannot resolve this name, right? This is not a. You cannot resolve this, right? So you need to work with your network admin team, and then kind of create a DNS which is publicly accessible, or do some kind of mapping. But for now, we are going to leverage a, because see, Nginx ingress, right? That's the piece of software which is sitting inside of this, like between us and the application. So we have this. My client is this terminal is my client apps, right? And I'm trying to hit this hello world running inside of this pod. And I have already created this ingress controller. I have an endpoint there. The only issue right now is I'm not able to connect to it. So for that, we need to get a public IP address. So what the good thing, what Ingress Nginx offers us is to get an external service, I mean external IP address of that Nginx server. So for that, there is a command all you have to do is go to kubectl and get services, and services for what? Nginx here. So this will give us an external IP address. You see here, Nginx, ingress Nginx controller type load balancer. We need to hit a load balancer here, and there is an internal IP, cluster IP 10.039.254, and then there is an external IP 20.121.253.174. So this is something we can use it. So I'm going to, wow, it didn't change. Okay. Um, so now this, and if you look at this command, what I'm trying to do here is trying to connect, right? So I'm just using a very rudimentary way of resolving this rtf.example.com on port 80, which is the not secure port here. So resolving this name to this IP address 21.21.253.174. You don't do that in production. Your network admin will take care of this. But look at that URL. This application has a hello world URL. So you got a response here. Hello world is the response. So we are able to connect to this application. That is good. In a non-secured way, we are able to connect. So let me pause for a while and take if you guys have any question. So we are here till now. We are at number 4. We created an AKS cluster. We installed the runtime fabric on that cluster. We configured, we created and configured ingress controller. We deployed a mule application. We tested it. It's working fine. Next 3 steps are we'll be securing the traffic, the front part, then the back part, then we'll just wind up and install and clean up. So any questions so far? Okay.
Yeah, I think
We good? Okay.
Yeah.
Okay, good. Okay, so now we'll be securing. So now we'll be securing the front end of the traffic. So the traffic between the client apps to the ingress controller with the lock, right? We'll be securing this traffic. So remember, I told that, I mean, you know already that anything to do with in Kubernetes is a YAML file. You have a template, which is, and all we have to do is customize that. So we need to customize that. So we'll go back to the same ingress template and add the security to that. Okay, so this is the template. I'll move to the other view so you can see the difference. It's not a whole lot. All I'm doing here, so if you see left, right, I'll let you explore. Okay, the only difference here is this spec. We're just creating these 4 line for security. We are again for demo purpose. I'm just doing a basic security. I'm doing a TLS. You don't use TLS in production, right? You use more sophisticated OpenID or auth-based security here. But I'm just using a TLS, basic rudimentary way of getting a certificate, getting a key, and then putting that in a secret example TLS. That's all, and we'll see how it's to be done. The first, the 2 things here we're doing here. One is so one is to change this template, this ingress controller, and then making it accept a secure connection, right? And then second part we need to do is like securing that Kubernetes cluster, because see, when the client app hits, it hits the cluster first, right? And then it hits the ingress controller. So you have 2 moving pieces here, right? So basically, both of them has to be modified to accept that secure traffic, right? So ingress controller, we know easy. We go to this template and then put this 4 lines of TLS. Host is what I would, this host we're trying to secure is rtf.example.com, and we need to create a secret, which we will do soon. And this you will fill up later, but again, we'll create the secret in Kubernetes cluster, and then we'll be able to um, test it again with a secure port 443. So for that, um, we'll create a secret, right? First, we need to create a certificate, right? Just a second. Okay. Okay. So we will create a certificate here, which I've already created. Um, use OpenSSL, and then what we're doing here is we're creating a key, which is a key.pem, and we're creating a certificate, which is cert.pem, and with a common name is rtf.example.com. So that's all. We're creating a key and a certificate, and then once we have that created, I've already created. So we have a key.pem, we have cert.pem. We have those two done, and to um, use that certificate and private key, what I've just shown you before, these two, and we need to create a Kubernetes secret. So for that, we need to, let's head back to our cluster. We do a kubectl, and we do a secret creation, create secret, and the name of, we're creating a TLS secret, and the name I'm giving it example TLS. And remember, the namespace are critical. So you don't know, you are only creating the secret inside of this RTF namespace. That's what Google understands to communicate with the resources. And my key is key.pem. My cert is cert.pem. Should work. Cannot read file key. Okay.
Can you try to give it in double quotes? That would work.
kubectl create secret TLS example TLS namespace RTL. Oops, my bad. Something called dot. Yeah. Key.pem, cert.pem. Yeah, that's great. So now this secret is inside of your Kubernetes cluster. It's not on your laptop. It's in the cluster because you're creating inside that namespace RTX. Okay, so we have that. So we created this cluster secret inside of the cluster, and then we have this ingress. Where did it go? Ingress TLS YAML. So we need to apply this first because now we have created this the secret right inside the cluster. Now we need to apply this. kubectl f ingress TLS. So now it's secure. So that's it. So just see how simple things are. I mean, an installation doesn't take more than a few minutes with configuring it. It just like know what to do. And once you know what to do, it's just a change YAML here and there, and then create, apply these YAMLs. Your configuration done. So it's pretty straightforward and easy. Okay, so now let's test it out. And this time we'll be testing using that same hello world command, but and this time I'm going to use port 443. So I'm doing a -v for verbose and example.com hello world resolve same way. But this time instead of doing, if you see previously we did 80 here, right? That's the non-secured port. So this time we're doing a 443. Yeah, we got a response back. So this is a verbose, so it just shows you a lot of TLS information here, all that uh, certificate saying fake certificate somewhere. Yeah, it's a self-signed certificate we created. So yeah, we got a response back. Hello world, connection to host intact, and got a hello world back. So this part of the traffic is secure, which is your until the traffic like between the client apps touching the Kubernetes cluster and then going to the ingress controller. So the front end of the traffic is secured. Now we need to worry about the back end of the traffic between the ingress controller and the pod, the application here. And just like you guys have done many times, securing your application with a TLS is pretty straightforward. So open your Hello World application, which I have done it here, and then go to global elements, put a TLS context, right? Usual story, and then put a. You have your basically after that you need to. You need a key store. That key store contains your certificate cert.pem or key.pem. You bring those two in and then package, and then create a key store file. And you have commands for creating a. You creating a, again. This command creates um, a key and a certificate, and then finally we are packaging inside of a keystore.p12, right? That's holding your key and the cert, and then that's what we are configuring here. Put that in your, the story. So src main resources, put that certificate here. This is the keystore.p12. That's the what we just created, and put that in here, and then refer that from this TLS context, and put your key password and the password, and that's it, done. And one small change here, and then we have an HTTPS port. You might see things like this is not like HTTPS port. We supposed to give 443 here, right? But I have given 8081. So this is a interesting difference. Um, See, this 443 port is already taken up by the cluster for its own by the Nginx security. So it's the 443 is already gone. So for the applications, so we are leveraging 8081 for both for HTTPS and HTTP, which is the only port available for. I mean, the 443 is gone. So basically, um, and the runtime fabric on Kubernetes listens on 8081 for both HTTP and HTTPS traffic. So we're giving 8081 here. And that's it. You package it up and export and then deploy, and export as a jar file, and then we'll re-import back here. I've already done that. I'll just show that. So I remember, so from a client perspective, nothing changes because you are only testing your curl is the same. You're hitting ingress controller on a secure node 443, right? And you really don't care how is the traffic behind the scene, whether it's a secured or a non-secured. The way of calling or invoking this API is the same because you're invoking a secure way, which is the front side of the traffic. The last mile security is something hidden, and that's happening inside. That's what we did. So your invocation doesn't change really. So if you see this ingress, we did apply, right? Why is it we applied? Yeah, not sure. See, it's saying, and we did apply this ingress TLS.yaml, right? We made it secure, so it kind of you have to reselect things here as an HTTPS. The name changed, right? So we selected HTTPS, and I am going to upload the file, the hello world HTTPS, and that's it. Apply change. I'm not changing anything else. Now see there are four applications here. See this? And can someone say why there are four? It should be two, right? We did only two replicas. The reason this is four because can anyone answer? You can type your answer in the chat window. So we did select. Okay, let me answer that. Yeah, that's correct, Sergi. So we haven't removed the previous app. Yes, we didn't have to remove. We have selected rolling update, right? That's why it's creating. Um, we'll see like this is still running so without stopping the traffic. It's a rolling update. That's why the four was there, and then finally came down to a final state of two. So that's the in transit state. If you do recreate in that selection, it will show only two. That's a good guess. I mean, that's a good answer. See, we have select a rolling update here. That's why instead of recreate. Okay, so it's running, and as I said before, you really you're from a curl standpoint or invocation standpoint, you really don't care how things are happening behind the scenes. I'll use the same command, curl minus v and minus k, all that, and with the same 443. Yeah, it's 443. Nothing changes. Oops, got something bad this time. Okay, so maybe it's not ready. It's become too soon. Just give it a while. Or am I doing something stupid again? Yeah, I did. Yeah, I mean, I didn't do anything. Connection to host left intact. That's correct. Bad gateway. Yeah, I don't see any. If you see any error here, the status should show running and I mean error, and you will see restarts. That's something restart because you are running a cluster, and you have selected with replicas, right? So it will try to be in a desired state of running that many number of replicas. Let's say if you select four or two replicas in this case, it'll keep restarting, and you like it because it's trying to maintain that desired state of two replicas, right? So even if it crashes one time, it will keep restarting. It'll go on an infinite loop. None of those fun stuffs are happening. So hmm, connection state changed. Bad gateway, something to do with the engines. Okay, so let me see my engines. Yes, yes, yes. I missed a step. So, remember, can someone guess what step? Okay, so Serge, you saying please check external IP. Yeah, I haven't changed that external IP. So that's not. So Jata, you're saying last man security issue controller. Remember what I did, just to do a flip back of what we did. When I did secure the traffic between ingress controller and the client, as I did two things. I applied a changed this template, right, and added a security TLS section, and then I created created a you know secret inside the Kubernetes cluster. That's how I was able to connect. But this time, I haven't done anything on this ingress controller. All I have done is securing the application, right? Um, so, so that step I missed here is like updating my ingress controller to tell that okay, now go and connect to this backend application in a HTTPS instead of doing a secure. So previously it was all unsecure traffic. That's by default, right? And if you don't define anything, it's a by default non-secure. I mean, non-regular HTTP, not an S. So now I want the ingress to talk to my application using a secure way. I need to go back to my controller and then apply, tell the ingress controller to kind of connect to the backend application using HTTPS protocol, right? So that's the step I missed. Okay, and that's the step is here. So again, I'll show you the before and after. I mean, into other view, ingress. So this is what we had in a plain, like this is what, so we had ingress template. We added TLS, right? We added these 4 lines, if you remember, right? That's all we did. Nothing, I mean, nothing more. And now we are. This ensures the traffic is secured from the front end. Now the back end, we didn't change anything. So all I have done is added an extra annotation here, and these are interesting annotations. So like, anytime these are all configuration of that Nginx controller. So all I have done here is in Nginx ingress Kubernetes.io slash backend protocol HTTPS. Done. Job done. 1 line and I'm done. Insert this annotation. Then ingress knows that to talk to backend, it can use now HTTPS. So I need to use this template. I mean, I just updated the same template. So now let's go back. Like this template now. Now it should. So my application is secure. It's accepting secure traffic, right, on a port 8081, and now my ingress is made um, to talk to the backend using HTTPS. So that bond is now established. Now that bridge is established now. So it should work. Let's see. Let's clear it out. Not yet. No. Just release to the plan. Okay, let me just restart the application. Let me ingress here. Don't change anything. Okay. Hmm, why is it not running? Okay. Should work. Go. Work. That's okay. We got a hello world back. Now all the connectivity is intact. I mean, bridged. So we're getting a response back. So now we have done a complete end-to-end security. So all the way from client apps to the pod, securing the front end, securing the back end. So that's pretty much it. Before I go ahead and do a cleanup, any question? This brings to an end of our session. So I have so over to you, Kishore. I have three questions. Um, how do you want to? Shall I
Yeah,
go
you
ahead and?
can proceed. Yeah, you can go ahead and yeah, you can fire your questions.
Okay, be ready with your budgets and paste write the answers.
Yeah, so what we are going to do here is, I think most of the audience is the familiar one. I can see all the names which have already like previously joined our meetups. So what we do here is Mani is going to show his first question on the screen, and after that they are going to give the answers in the chat. The first three is going to get picked, and after that we are going to do that wheel of names. Whoever's names comes and that they will win a voucher. And we are going to do that for the other two, like total three questions.
Okay, here is the first question.
Okay, so we have the question. Okay. So most of the answers are like the first, any minor version 1.22 or higher. Is that the right answer, Money?
Are we done with the answer? I mean, are we done with the response? Then
Yeah, we have response in the chat.
okay. So, as I was showing before, you
Mhm.
have only selected versions of 121, not all. So four is the answer.
Oh, no one has given that answer then.
Remember, um, yeah, these are some there are some um,
Okay. Yeah, so I
you
think
know that's okay. I mean, I'll just show you one more time.
yeah.
When I was showing you creating in right here, um, when you create a resource, Kubernetes service, you have I was showing you initially, right? So you have the option of selecting many versions.
Mhm.
Yeah, here. So I was saying, yeah, I was telling the story, right? When I tried and burned my finger all of this. Like you cannot do 23.5. Yes, it looks nice, but you cannot do that with 112
Yeah.
RTF. So you can only choose these two. Very selected. Like
Yeah.
last week, it was showing 20. The documentation says 21.3, but it doesn't even show here 21.3.
Mm-hmm.
You know, so always refer to the documentation and see which is what is listed there. It says documentation says 1.21.x, um, like version zero point 0.3 or higher,
Mm-hmm.
but zero point 0.3 is not even listed here. It's only zero point 0.7 and zero point 0.9. So you have very limited selected version out of this 1.21.x series.
Okay. Okay. Yes. So I
We
think
can we'll select on the next two questions. Those are
Yeah, yeah, Anurag. Maybe what we can do is maybe we can pick two winners from the next question, right? And
okay.
we
Okay. Let's do that. Yeah.
okay.
So the next question is, what is the best option for log forwarding if you have Titanium subscription? Select all that apply.
Or don't
So
select all that. Okay. So
We have answers here. So 224, 124, 124, 14. Okay, what is the answer here, Money?
So use, like, if you have titanium, right? And I'm saying best option,
Mm-hmm.
right? You have many options. All are correct in this answer. Well,
Mm-hmm.
except, so if I remove the word best option, you
Mm-hmm.
can pretty much do, the answer will be pretty much one, two, and four.
Okay.
If
Okay.
I'm saying what is the option, or what are the options, basically,
Mm-hmm.
select
Mm-hmm.
all that apply. If I change this question, then it'll be one, two, four. I'm saying
Okay.
the best option means there is only one option, right? Best in the sense is one, right? That's,
Mm-hmm.
and then number two will be the answer. I use any point monitoring. If you have titanium subscription, there is no point of playing around things, right? You're
Okay.
already paying for it.
Mm-hmm.
So number two will be the only answer.
Okay.
Anyone has that?
So we
Yeah,
have
so I think Sujata and Sarjay both are. So I think we can give Sujata and Sarjay. We
Okay,
don't
cool.
we don't have to do wheel of names here. We have
yeah,
only two correct answers.
yeah.
Okay.
So Sujata and Sarjay, you can give your email IDs in the chat. Congratulations, you are winners for like. Okay.
Congratulations to both of you. So next questions.
Hmm.
This one is from my previous meetups. I was a bit lazy to write type the third question, so I just used it.
Okay. Mm, okay. Uh, so we got few answers. Uh, Question is, which of the following configurations are customer responsible when adopting runtime fabric on self-managed Kubernetes? Select all that apply. So we have the answers 1 and 3, 1 and 2, 1 and 3, 1 and 3, 4, 1 and 3. And Siddhiraju has given A and C. So I'm assuming like 1 and
Yeah,
3.
one and three. Yeah.
Yeah. So what is
So
the.
if you look, yeah, if you look at this diagram, right? This
Mhm,
tells all. So you have ingress controller, which is our number one,
mhm.
and then logs and metrics, which is number three. So one and three are the answers.
Okay, so we have 1 and 3 as Siddhiraju, Jinu, and not Mohan K. Again, Siddhiraju again, and Ganga. So we can do a wheel of names here. So I'll put their names on. Uh, there is this tool that we use.
So while
So,
you use that, I will show cleanup.
okay, yeah,
I don't want,
that's.
yeah. Okay, so we are going to clean up, right? I mean, you don't do that. I'm just doing for demo purpose. You don't wipe out your environments just like that. So we do RTF cuttle and uninstall, as simple as that. It says, okay, you want to confirm it? Yes, sure, I want to do this. You don't want to pay any cluster charges, so confirm. And see what is happening. What you see on the screen, you have different namespace, right? So you have three namespaces. RTF namespace, right? What you see, anything to do with RTF, you have an agent, you have a cluster. And remember, your Mule application is not inside of this RTF namespace. It has its own namespace. Right? This hello world. The agent talks to that application, but it's not in that namespace. And then you have this cube system, that's all the clusters, right? Now, like when I'm cleaning this up, I'm doing a RTF curl uninstall. So what it will do is only wipe out the RTF namespace from that cluster, all these. So that means your application will be not in a good condition because you just lost your cluster, but it will still be there. The namespace will still be there, and your there's another ingress nginx namespace, right? Um, and then you have your AKS cluster cube system. So only thing which is being removed with this uninstall is your RTF namespace from this cluster. So we do that here, and then we go back and then manually remove that from your runtime fabrics. So this one, I need to click manage, delete. Now look, before I do that, look at this. System is disconnected from Anypoint platform, showing last known snapshot. So it's now in a split brain kind of thing. It is just lost its. So this is a Amazon, right? This Cloud Hub running on, and now you just deleted everything from Azure. Now the connectivity is broken. Now that's why it's complaining. System is disconnected. Anyway, it'll just go in a pretty bad state. So I'll just delete it. Now see disconnected. Manage, delete. And remember, there is an application running on this. So, you ideally, the best practice is remove that first and then do it. I'm just going to do a force delete and just wipe out everything. Application gone, runtime fabric gone. Yeah, this will take a while. See, it's clean from here. You don't have any RTF. RTF namespace we just removed using that RTF Cuttle uninstall. I wiped out that application from runtime manager portal, so that namespace is gone. And the only thing remaining is Ingress Nginx, which is not a component of the runtime fabric. It's an external component that stays there. And you can remove this in a different way using kubectl command, or you just use, and then the cluster is still there, which I'll keep it running. Or I'll just remove that, doesn't matter. And so few commands, these are all kubectl, right? So if you just Google kubectl cheat sheet, that's what I use to. I have my own cheat sheet for kubectl cheat sheet here, because this is very helpful. Once you like, these are basic commands. You can do all that, logs and all that. But yeah, keep that handy all the time. You'll be using that pretty often. And then always remember to have that compatibility metrics. But most important as a takeaway from this session, I would say it's very simple to install and configure things in a Kubernetes environment. So this is a very, I would say, very sleek offering, and makes sense if you are running in Azure or Google Cloud or AWS. If your enterprise runs on all these three, this should be your first option instead of thinking about cloud or thinking about. I don't think people even think about runtime. On-prem when they're already in the cloud. You know, so you have this is a better offering out of. Again, it's all depend on your situation, right? Where you are. If you're in a hybrid journey, you can have all three. You have a license. You can split a license between something on-prem, something cloud hub, something on Azure. So you are in a phase of migration between all this whole cloud. Nobody has done complete. Many of the organizations I work with, they are in different stages of their modernization journey, right? And I have seen all this together.
Yeah.
And then once goes down, your uses of runtime fabric will be increasing, decreasing on the on-prem or decreasing on the cloud hub. Again, it's MuleSoft is pretty flexible, and this is a very easy offering. It just depends your situation, which one you want to do. But things are pretty easy from a MuleSoft standpoint.
Yeah.
And yeah, but the big catch is like you need to know a little, because this is for client who has good Kubernetes experience, right? So so keep that in mind. And
Yeah. Yeah.
okay, that's all. With that, I
Yeah.
come to the end.
Yeah, thanks a lot, Mani. I think it was really very helpful session there. If you stop presenting, I think I just need to share my screen, and
Sure,
we
I can
need
do.
to. Okay, so you guys are able to see my screen. Let me know. Money, can you see my screen?
Yeah. Okay.
Okay, and it shows that wheel of names. Okay, so if I click here, I think for the third question, we have to find out who is the winner. So winner is Ganga, and congratulations, Ganga. Uh, Please share your email ID in the chat so that at the later stage, I think we have to give the vouchers for you. And thanks a lot, Money. It was really helpful session. Uh, we wanted to cover this up for a longer time, and uh, it was possible because of you, and it was great demo as well. I also got to know a lot about how we can implement the RTF in Azure.
Oh, thank you. My pleasure. This is an interesting topic. I mean,
Yeah.
this is my fourth session on the same topic, by the
Yeah,
way.
yeah.
Yeah.
Yeah, it is because, and actually I wanted to cover it since long, but I think I was not able to find out the actual like speaker for this one, and now you agreed, so yeah, thanks a lot. uh Thanks for your session, Money.
Yeah. Thank you. Thank you, everyone.
Yeah, thanks everyone. Yeah, have a good day. Bye bye.